Anomalous behavior of beryllium. As I told you just now, beryllium, due to its very small size and high polarizing power of Be2 plus, it differs in some of its properties from rest of the alkaline earth metals. Here we are going to discuss the points of differences between beryllium and rest of the alkaline earth metals. Let's talk about them one by one. Number one is beryllium oxide is soluble. Let's see the important points of differences between beryllium and rest of the alkaline earth metals. Number one is regarding beryllium oxide. Beryllium oxide is amphoteric. Beryllium oxide is amphoteric. All other alkaline earth metal oxides are basic. We mean by amphoteric, we mean it can behave both as acidic oxide as well as basic oxide, or we can put it in this way: it can dissolve in both acids as well as alkalis. Beryllium oxide is amphoteric. Number two is beryllium fluoride is soluble. Beryllium fluoride is soluble. It is because of high heat of hydration of Be2 plus and F minus. Both are very small in size. Their heats of hydration are very high due to high charge density. Other alkaline earth metal fluorides are insoluble. Magnesium fluoride, calcium fluoride, strontium, barium fluorides are insoluble. Only beryllium fluoride is a soluble fluoride among alkaline earth metal fluorides. And the reason is high heat of hydration of Be2 plus and F minus ions which are produced in solution. Number three in the list is BeCl2 is polymeric and contains bridging chlorines. While others are predominantly anionic, beryllium chloride is covalent, predominantly covalent. Because of that, it is electron deficient, and due to its electron, to overcome that, it has to adopt polymeric structure we have seen under halides of alkaline earth metals. It is polymeric and contains bridging chlorine atoms. Number one. Number four in the list is regarding covalency. Maximum covalency is 4. Beryllium, unlike other alkaline earth metals, beryllium does not have vacant d subshell in its valence shell. That's the reason why beryllium can have a maximum covalency of 4. Its covalency cannot go beyond 4. It has only 4 orbitals in its valence shell. You know very well, 2s, 2px, 2py and 2pz. These are the subshells, orbitals which are present in the valence shell of beryllium. That's the reason it can show a maximum covalency of 4. So these are important points of differences between beryllium and rest of the alkaline earth metals studied under this anomalous behavior of beryllium.